Hello, everyone. Welcome back. This is Sachin, and this is one of the last topic on this series. We were discussing about the producer, and next we will discuss about consumer in the next session. Um, so far, like we learned about how you can quickly up and running the Kafka cluster in your local development environment for all your testing purposes. We learned about how to send a producer message, receiver, and receive on the consumer side, how to receive those messages. Uh, we also learned about how the producer internally works. We talked about uh, how as one thread basically pushes the message which goes into buffer memory, another thread which takes this message and actually push into the broker side. We also looked about the various, depending on the use cases, how the various producer you can use for different kind of guarantees. So this is the last session about the producer, and I will be closing that with how to write your custom producers, which I promised, and basically some of the important configurations which could be used on the producer side. So let's get it started. All right. Okay. So let's just start with custom partitioner. So I have written a class, and pretty much anything you can basically in Sketchukla Kafka project. All right, you can go to this GitHub and see the source code, but pretty much once you check out the source code and set up your ID, you will find that there's a class called custom partitioner. So this is pretty basic. We talked about when a producer is pushing that message, producer does a couple of things. The first is serialize the message, and then either based on your custom partitioner, or if it is not provided, it uses the default partitioner. It finds for that topic which partition the data should go, and finally that thread push that message into the buffer zone. There are multiple batches. Once this job is done, another thread picks it up and actually takes it to the broker side. So custom partitioner is like when you are telling you want a control that depending on a message, which partition it should go. So one of the few use cases could be like, let's say you are pushing some message into topic, but few of the topic you want, like, they should go into few of the messages you want to go into a specific partition. Maybe you have a other consumer running which is like, taking that partition as a high priority and want to consume message. Use case could be anything. So that's where the custom partitioner comes. It gives a more fine-grained control for your program, your producer client API, to push that message into a specific partition. All right. So this is pretty straightforward class. When you write your custom partition, make sure you implement the partitioner interface provided by Kafka. And it has like a couple of methods to override, config, close, and like just writing a pretty basic ones. So it gives you an idea how the partitioner can be used. And then this method with the signature. So you have all the information about your topic, your key, your value, and of course there are bytes and the cluster. So pretty much we are just going to use a few little information. So we know that we are it's just for POC purpose to give you an understanding how the partition works. So it's just a string, comma string. The key value is only a string, but it could be any complex object, Java object, as long as they are serializable, because end of the day, everything is into byte array. Kafka is agnostic in that term. Okay, so the first, using the object, we got number of partitions, which is currently running for the topic in the cluster. And I'm just printing that how many number of partitions. And if it is not in a string object, I'm just returning 0, basically the first partition. But that's not the case. The code will not come in the if block, because we know this is of type string. Now it comes, we typecast it to string, and basically based on a %, we know that we are just going to send 1, 2, 3 as a key, as a message key, and then just converting to %. So I know 1, 2, 3, 4, 5. If I send, I'll always get an integer. And again, we know number of partitions. So in the previous section, we use the 3 partitions. So that's the same thing. I'm going to use it over here. Basically, any message which comes will be either in the partition 0, 1, or 2. And this message I'm printing, like, what is the key, what message, and what partition it has gone. All right. So in my configuration, just switching my topic to test topic 2, because in last session we saw the test topic 2 is actually the topic which is 3 replication factor and 3 partitions over there. All right, so let's get started. Okay, so right now none of my containers are running. I'm still in the same directory. You're already aware about how to bring up Kafka up and running. Just run that script. If you're using Mac, super simple, just need to check out and run these scripts and your Kafka brokers will be up and running. Okay, let's give it a few seconds, guys. All right, it seems like my cluster is up. So let me change my topic to test topic 2. So I'm starting my console consumer. So whatever message I push, I know they will be printed over here. Pretty well. Again, test cases are the best to test all these scenarios. And I'm going to run the same code which we ran last time while we were discussing about what are the various ways you can actually make a call from your producer. So again, so this is what I was talking about. I know my key, I'm always going to send just for POC purpose to make you understand that how the partitioner works. So this is my key and this is my message. And push method does nothing. It just uses this API and we create a record and we know for that topic with that key and the value it is sent over. Okay, so let's get run. I'm expecting 5 messages coming here. Of course, I got 5 messages once everything is good. But we need to check the partition, which message went into which partition. So as per our logic in the custom partitioner, we know this message, the key is 3 because it is here like this. This message has a key 3. And when we take a modulus with the number of partitions, which is also 3 in our case, because we know our test topic 2 has a 3 partition with partition 0, 1, and 2. Okay, and as per our custom logic in the partitioner, we take this key and we take with the modulus with the number of partitions, and that's where for this 3 you get 0. Basically, it will go to the first partition. 1, it will go to the second partition because partition would be 1, and 2 will go to the third partition. Now, once it comes to 4, which you take modulus with 3, so the remainder is 1, so which means you go to the second partition, and this will go to the third partition. So let's check the output. All right, so message push to partition 0 with offset 0. Did I use? Okay. All right. So basically, we need to use the. We need to enable that it should use this custom partitioner. Just by putting the class, it's not going to use that. So there must be some partitioner class. Okay, partitioner.class, and then we need to provide custom partitioner.class. Okay. All right. So now, while bootstrapping, it will understand that it has to use this custom partitioner. All right. So let's rerun it once again. All All right, here you go. And I see something is getting printed. Here you go, number of partitions. So let's go to the custom partitioner class. And this is what it is printed. So it understands that for this topic, there are 3 partitions. And this is the message actually which we are interested in. So let's highlight them. Okay, with key, yeah. So message with key 1, of course, it has to return the partition as 1 because it takes modulus with 3. And similarly, message with key 3, it goes to partition 0 and so on and so forth. So this is the expected behavior. All right, so that's pretty much how to write a custom partitioner. Now, before closing this session, I want to discuss about some of the important configurations which we can control based on our use cases. So let's get back to our slides. Okay, acknowledge. When you are producing that message, these are the, okay, I'm sorry, this is not a broker configs. This is producer configs. So let me producer config parameters. Okay. So few things which, I mean, there are various configurations. You go to Kafka official documentation, you'll find plenty of configurations, but I found few really useful and something which you should be aware about, so you can tweak them based on your need. So the first one being ACKS, stands for acknowledgement. So 0 says that you just push the message. You don't care about whether it has been written in the disk, whether the commit has been successful on the broker side or not. So that's what 0 means. 1 is at least one of the broker nodes where your message has been successfully written, and then the response, and then only the producer API will return a successful response. And that node has to be, of course, leader node, because we know a leader node for that message, of course, because we know once you write a message based on the key, your producer will put that message into that specific partition. By the way, one thing which is very important to understand about partition is changing a partition once your application is up and running, and in future it's a little tricky and difficult. And something which is impossible is you cannot reduce the number of partitions what it is currently running. You can always increase, but you cannot decrease that. So just bear in mind. And all says when you are pushing a message to broker, till the all. So basically there is a concept of ICR. I know I haven't discussed much in details. It stands for in-sync replicas. Basically, whenever broker is running, and if you remember from our previous diagram, if we push a message and let's say it goes to broker 2, there are real-time syncing happens if your replication factor is 3, let's say. So this message will keep syncing into other nodes for to safeguard us from the failures, right? So this message 1, which is an original message designed in the broker 2, but the copy which is donated with red color will be created, let's say, in broker 3 and broker 1, and similarly for other messages as well. So coming back to this, whenever you are pushing a message, there are in-sync replicas where the real-time syncing will happen. But if you want to ensure that the message which you have put should be synced in all these replicas, you need to wait till that time. At that time, you need to give the value as all. So these are the 3 configurations allowed for ACKS parameter. Buffer memory. This is again one of the important parameter, I believe, because if you recall from our previous sessions, when you push a message after serialization, after finding the partition for the topic, that thread just dumped that message into a buffer area, and this memory is donated. I mean, this whatever configuration you give denotes that memory, how much messages, how much message memory you reserved for those messages. And of course, if your application is very aggressive and is pushing a lot of messages, it's a good idea to basically increase this memory. Compression type. So basically, compression type is like when you're pushing your message, Partitioner APIs can actually compress a message and then send that. gzip being one of the option, and I think there are other compression algorithms as well which could be used. But one thing to bear in mind, once you compress that, it goes into Kafka, and the broker decompress that, evaluate it, and at the time of final saving it again compress that. So just bear in mind when you are tweaking this parameter what kind of compression algorithm you're using, because based on that it could be a little CPU intensive. Linger.ms. So linger.ms is a configuration which tells that how long the Partitioner API will wait to push that message into the broker. So I think the default value is 0. We can quickly check later. So there are a couple of parameters like they overlap with each other. So for example, buffer.memory. So this is the memory, like if one, once you push your message into the buffer area, if this memory is full at that time, the Partitioner API will flush that messages, or the linger.ms time, whatever reaches early. So it's not like that if you have given too much of buffer memory, then it needs to wait for memory to be filled for pushing that message into broker, because let's say linger.ms is a shorter interval, which whatever reaches earlier, at that time the message will be flushed into the brokers. All right. Retries, as the name suggests, it's basically the number of retries. So whenever you push a message, the Kafka internally does the retrials, and there is a default retrial count which we will see right now after the slide. But pretty much Kafka Partitioner API internally will do all that retrials, which could be retriable. I mean, there are some errors which you retry can be fixed, but some errors which cannot be fixed. For example, let's say for a very short time when your Partitioner API is pushing that message, there's a little network loss that can be fixed by using this retrial, which Kafka internally does, and we don't have to write any specific logic at our end. But there are some errors which, even with the retrial, they cannot be fixed. For example, if let's say you are sending a message which is too bulky, and broker is going to reject that based on max or dot size or something like that. We can Google that, but there is a specific limit at the Partitioner side as well and at the broker side as well. And if you're sending a message which is more in size with that configuration, definitely even a number of retrials are not going to solve that problem. So as an application developer, we just need to focus on those retries which cannot be solved by Kafka. Okay, the next is max in-flight request per connection. I believe this is one of the important parameters which we should be aware of. So basically, the thread which is responsible to push a message into that batch or buffer area, this number tells how many such messages can lie over there. I mean, the batch which can lie over there, which will be pushed. So basically, if you want to guarantee that you have a strict ordering guarantee, basically you cannot, when you are pushing a message, it has to be in the same order which you are pushing. So it's desirable to put this value as 1, because once you put one single message, and then another thread will push, and then only it will try for another batch. Consider this value is, let's say, more than 1. So let's say 2, for example. Now the thread which is like pushing that message into that batch or buffer area, it has pushed multiple 1, but for some reason the first one is failed, right? and then second one is successful. Now, again, because I said there is a retrial, the producer itself will retry. We don't need to worry about as an application developer. And for the next retrial, the first batch has gone. So which is like altering the ordering and belying the purpose if we have a strict ordering guarantee. So make sure this is a very important parameter. If you want to guarantee that you have to maintain the order, this value must be 1. Request timeout.millisecond. So basically this is the configuration, as the name suggests. This is the time limit uh, which producer will max wait before erroring it out. And the max request size, the default value is 1 MB. Basically, if you're pushing a message, one message cannot be more than 1 MB. Or like if you're sending a batch of message, then individual message count cannot be 1. It has to be less, like as long as the total size of that batch is less than or equal to 1 MB. All right, so let's quickly try at least few of the parameters. So at least we get an idea that how we can set these values. So it's always good to have a little hands-on, so it doesn't feel like a pure theoretical session. So again, to set these configuration, we need to go to Kafka template, and here is the right place to put that configuration. So let's try, okay, linger.ms. Okay, let's try linger.ms first. Linger.ms. So basically here you can see the actual value. Producer config is a Kafka internal class which contains all these keys for the configuration. And so by default, as we said, linger.ms actually decides how long max Kafka, how long Kafka will wait the producer API to push that message into the broker. So basically, again, various configurations may overlap. So one is like buffer size, another one is linger.ms. So which means if either the buffer is full or the linger.ms time has been reached, so whichever reaches earlier, it will push that message. So we know buffer.memory is a decent size, and we are sending a small message. This will not fill that one, at least for our demonstration purpose. So linger.ms is gonna be a deciding factor. The default value is, I think, a couple of hundreds of millisecond or maybe 100 millisecond. We need to check. I think linger.ms is 0. So which means that immediately send that message. If we have run this last program, I think we can see what's the default value because we haven't altered it yet. Yes, so the default value is 0. So this is what we're gonna change. So let me take it to 5 seconds. So which means now we are sending a message. They're gonna take a little while to reach to our broker. So let's see, I'm gonna clear it off. And yes, so let's go to our test cases and run that test. So it has pushed it. It hasn't come yet. Maybe let's wait for a couple of seconds. Must have come by now. Application properties, test topic 2. Is it test topic 2? Yes, it is test topic 2. Okay, and let's send that message. I think I need to wait for that. So I'm gonna run this test case, but I'm gonna comment her because I don't want to send 5 messages. Testing.ms config, just for my reference. Pushes that. Okay. Config. We have already given 5 seconds. Okay. Let's run that. So yeah, because last time we haven't, it was like kind of a fire and forget. It was not waiting for it, for the response to get. So here we see that even once the program is run, let's rerun it once again so it is like a little more clear. So we are printing. Now this is running and it's actually waiting. I mean the linger.ms, because of that configuration, it will take a little while to push that message. Okay, there are a couple of other configurations. Let's at least let's check one more. Request timeout.ms. Okay, so let's go to config. Request timeout.ms config. All right, so request timeout. The default is 30 seconds. I'm going to override that. So as said, this is the timeout. Kafka producer API will wait, and after that it will error it out. If it's still the message is not gone, so I'm going to reduce it just to 1 millisecond, so I can produce that error. And we see that still it will not work as expected. We will not see the error. I'll just explain why, but let's run with this configuration. So our expectation is like, because this configuration says how much time max the producer API will wait before erroring out. So expectation is, because it is 1 millisecond, which means immediately, immediately we should be expecting some kind of an error. So now let's rerun the same program. Okay, we were like kind of expecting the program should be done and we should see some kind of error, but that didn't happen. The reason being, it is actually having a retry, and it is actually doing a lot of retries, because if we see the retries count is like too much. So let's give some meaningful, very small retrial count, and then once these retries are exhausted, we are expecting to see some kind of an error. So retries config. So retries, let's give 3 retry configs. So this will try 3 times and expecting the result to be available within 1 second. If not, it should give us exception. So let's rerun the same code again. Let me clear it off. Linger.ms. Let's put some retries count. Okay, let's run that. Testing retries count. I just ran once. Config. What happened? Retries config 3. It's 1 millisecond. If I test that message. This is quite interesting. Testing retries count config. Why it is? Okay, because it is retrying it 3 times. Interesting. Let's run it in an asynchronous way. Request timeout millisecond. It's 1 millisecond. Demo application. Let me switch back to a normal topic. And let's test. configuration we can try is Sky, and let's quickly run this code. Custom partitioner. Let's don't use the custom partitioner for now, and let it use its own default partitioner. Very interesting. So, I see. Okay. Because I think this is sending that message, which, okay, let me print the stack trace, extort print stack trace. All right, here you go. So basically, this is what I was expecting, but maybe I think we haven't put the stack trace. I was not able to see the error logs in, and it was lost in the logs maybe. So basically, this is what the expected behavior, because we're just trying 3 retrials, and we are saying, okay, request timeout.ms is 1, which means if in 1 millisecond the response doesn't come back, you need to error it out. And that's what precisely it is doing, because it will take at least a few milliseconds, definitely more than 1. And because in 1 millisecond the response is not coming back, it is resulting into on failure. So that's pretty much for today's session. I think we are almost done. I think most of the things we have covered about producer APIs. Next session, I will be covering the consumer side. I start with the basic consumer, so we know how to write a consumer in Java and read some messages. And please subscribe to my channel. I will be putting more and more videos on Kafka, and maybe more in future as well. And do like and comments. Thank you.